In this section, we are going to talk about the particles and how can we create a scene like this that it will be used as a background in your website or in your game, which is beautiful. And let's see an example of the particles inside the Three.js. As you can see here, there's a live demo of the particles. And the mouse movement is actually different, and as you can see, the particle lights, the particle color will change during specific times. And as you can see, in our cases, the mouse movement is actually different from this example. And actually it is really beautiful for the background of your website or some cases in your games. And there are another actually example here, which there is a multiply type of particles. As you can see, there is a movement in these particles, and some of them actually moving, some of them falling, some of them rotating. It's based on the actually same logic. And as you can see here, this is the most advanced example, and it is time consuming. However, it is so beautiful, it's fantastic, and you can actually evaluate these works. And but the logic are the same. Okay, so let's see what we have to do. First of all, we need to actually search in the Google this PNG. I just downloaded one of these PNGs and actually move it into our static directory. And afterward, we are going to load it inside our environment. You can use another PNG, another type of devices that you want to show as a particles, and it is based on your actually project. Generally, each particles is represented as a point. As I mentioned in the previous videos, the cube actually consists of 8 points, that each point connected to the corresponding point, and it will make the cube. And in this example, actually we randomly created this point, and afterward we append a PNG, a disk PNG, to each point, and as a result there are multiple random points in our environment, and there is a disk PNG related to that point. First of all, we initialize our code, and afterward we actually create a buffer geometry. The buffer geometry is a type of geometry which is which is in the first moment is empty, and after that we have to actually append this point to the geometry, and we created array, and actually by using this array we are going to actually push these points into the array. And afterward we actually load the texture, and we actually create a texture loader and load this PNG. And how can we actually create these points? We can actually use the math.random, and there is a XYZ axis. So our coordinate system is based on the XYZ value, and we can actually create create a for loop, and afterward we start from 0 to some specific lengths. For example, if I increase the number of the particle that we are going to generate, the points will be increased, and it is actually based on the application that you are creating. And in this example, I just create a random and scale it by some constants, and decrease the space between actually these points. And as a result, you can see actually as a result, if we increase this value, you can see each of them will be represented in some specific point inside our environment. And the reason that why we are not able to see these points is because of the camera. It's in perspective camera. In the last parameter, we says that in 1000 units you have to render, and if we increase the number, you can see that we actually create the environment with a lot of disk, and it is so beautiful. You can use it as a background of your website. And in this example, you can see you can be innovative with these features and so on. We can actually change these values based on our application. So let's revert the changes. Okay, from now on, actually we discuss the basic, how to create, actually how to generate these points. And actually we have a geometry, buffer geometry. We created points, and each time the XYZ points created, we actually push the XYZs to the vertices array. And actually inside each geometry, we have a function called setAttribute, and in setAttribute, we have two parameters to pass. The first one is the attribute that you want to be set, and the second one, the values and the functions. In here, we have a geometry set attribute on the positions property, and there is actually function here, float32 buffer attribute. We pass it the vertices, and we set the second parameter to the tree. What that doesn't mean, if I actually see it in the documentation, actually I think I need to search it on Google. Three.js, yes, in the buffer attributes. As you can see here, there is a buffer attribute types. You can see here there is a float, unsigned int, and so on. And in the constructor, it's actually said that we can pass the array, item size, and normalized. In array, we can actually we passes the vertices array, the pointers, and the item size was 3. What that is mean? It means that we actually split the array by 3, and each of 3 number represented a point in our system. And as you can see, we by actually applying this, we can have a three-dimensional actually environment. And whenever actually pass the item size, for example, instead of 3 to set it to 2, it means that we have xy coordinate system, two-dimensional coordinate system, and our coordinate system is not actually 3D. You can actually apply it by yourself and see different changes, and as you can see, you can actually set it to 1. It means that all the points are in one axis, which we can call the axis X. And as you can see, we actually split this array by 3 and set the attribute to the geometry. So after we actually set the attribute, now we are going to actually create a material and pass the material and geometry to the point. We use actually 3.point materials, and let me see the documentation. Actually, as you can see here, there is a code provided that you can actually study it by yourself. There are some properties that you can pass it, for example, color, map, size, and others. The map actually is our textures, and from now on we are going to actually apply it in our code. We set the point size to the 35, and if we actually change it to the 50, you can see the changes, and the 500 will be actually applied, and each point size will be increased. So you can actually find your appropriate size, and after that there are some property, which one of them is transparent. We set it to true. Actually, transparent helps you to show the image smoother, and your image will be shown better. So I revert the changes, and actually whenever you have a colorful background, you can see the different changes, and I apply the material color, and as you can see, this is a raw format of the this PNG. I just added additional color, and yeah, that's it. So afterward, we need to actually map the textures. We load the textures before in previous lines. As you can see, we use a texture loader to load the PNG, and actually we pass it to the variable spread, and from now on we actually assign the spread to the map of the point materials, and as you can see, we can see the changes. Each textures have actually a fully dimensional size, the dimension of your PNG, and you can actually remove the additional part by using the alpha test. As you can see here, I set the alpha test to the 0.5, and you can see the changes. As you can experiment by yourself, you can see the changes. The value should be between 0 and 1, and actually you can set it to even 1. However, it will be removed some of your some of your object from the PNG. So you can actually experiment by yourself, and as you can see here, you have to set it by experiments. I just set it to 0.5, And afterward, you can see the changes actually. And again, we apply the transparent to see the PNG's more realistic way. Okay. From now on, we are going to actually change the particles from the PNG to the shader. And what is shader? Actually, shader is a type of material that a shader is a small program written in GLSL that runs on that GPU. And actually, shader is a type of material that the GPU, the graphic card, will be understand how to actually react to the changes on the environment. And as the documentation explained, there are actually multiple example here. These are such a point that are not actually PNG file. These are shader that graphic cards understand how to actually act and implement to create these actually colors and these objects and texture. These are actually the code. These are not the PNG format. And as you can see here, you can actually see more example. These birds are not generated from the PNG. They are generated from actually graphic cards. As you can see here, you can change these values and see the changes. There are multiple actually live demo. You can actually see these demos and see how to implement these example. Creating shader actually is a really sophisticated task that you need to understand and learn GLSL in order actually to create a shader. And there are some predefined shader on the internet and you can use it from there. However, you can actually learn about the GLSL programming language and how can you actually create a shader using GLSL. However, in our video, we are not going to actually use the GLSL program language to create a shader. We just use a predefined shader and append it to the particle. So you can actually use these examples in order to append these shader to your particle. From now on, actually, we are going to see the different things in here. We actually map the textures from this PNG. However, actually, before we append our shader to the particle, first of all, we need to understand how can create a colorful particle. And it is not related to the material. You can just actually set the colors to each related point. And as a matter of the fact, there is a set attribute. We can use it as a color. And in opcode, actually, we created RGB color randomly. And as a matter of the fact, we append the RGB created in each iteration of the loop and append it to the color array. And afterward, actually, we set it the color to the attribute of the geometry. And as we previously seen, we split each tree number in the colors array, and they are represented as a RGB color. And after that, we set the attribute. However, and before that, we need to actually set the vertex color to the true in the point material. I just wrote it twice. Let me actually remove one of them. And afterward, we can see the changes. As you can see, there are colors here. As you can see here, there are congested. So I set the size to actually we have to increase the gap between each point, and I can just apply it like this. As you can see, as a result, the colorful pointers are spread in our environment. And actually we can make the particle to the circular, and we can append the color to the texture, to the circular textures. And you can see that let me find a texture, a circular texture. We need to go to the static folder, and there's actually a spark or a disk. However, I use a disk for the simplicity. And now we just need to actually load the disk as a alpha map. And after that, we set the color to the alpha map. We create an alpha map loader using Three.texture loader, text loader. And the texture loader, we pass the PNG as a parameter. And we set the alpha test to the 0.5. However, it seems that our texture is not fully suitable for this work, so I can just download it from Google. As you can see, you can just search it alpha texture circle, and afterward I can just load it like this. So you can see that we have now a colorful circular point in our environment, in our universe that we are created, and you can explore it inside the environment. And after that, we are going to actually make this particle rotate, and we can add the animation to these particles. So first we create a geometry. After that, we set the attribute position and color to the geometry. We create a point material, and after that we pass the geometry and material to the point. So if you want to use the particle inside the animation, we have to make it global variable. And so in the animation function, we are going to apply our animation. So we write the particle position of the x-axis. Each time assign the previous position to the 1. We add it to the 1. Let me see why it's not rendering. Oh, okay. As you can see here, it's now the particle move. And after that, actually, we can set that the particle rotation in x-axis to be assigned the previous. It's too high value. Actually, let me set it less. And as you can see here, we have our animation. And this is default by the actually environment, and you can drag and drop the particle by yourself. And as you can see, after we drag the item, it will be continue the animation. In the last stage, we are going to actually use the shader as our particle instead of using a PNG. Again, it is a very sophisticated task. However, I'm going to cover some part of shader here. As you can see, I defined 3 variables: particle count, cube position, and cube material. As you can see, the procedure is like that. We have to, first of all, we have to create some points, some particle. So I define the particle number that we are going to use. And after that, each particle have their specific X, Y, Z positions. So I creating a for loop, and as you can see here, there is some code that you can write, it and read it by yourself. And I iterate from 0 to the particle count and create some positions. And in our particle is a cube, so we have a cube position. And after that, we actually set the attribute of the position and the size, as we did it before, to the cube geometry. And from now on, actually, we created shader material. Shader material is a sophisticated material that you can see the documentation. However, the documentation is not fully functional. You can see the example by yourself, and as the examples shown in actually documentation, you can create your own shader material. And each of these particles will actually use this shader material to generate ourselves. And there are some attributes that I'm not going to cover. And as you can see here, after we creating our point, we creating our geometry, we creating our texture material. Now we address the GPU to create this scene.